Alright, this is the lesson on the rational root test. We're going to do a quick warm-up today. We're going to look at some extension questions from the previous lesson. Have a little practice on that, and then we're going to recap the rational root test. And we'll also look at the factor theorem as well, which is really important. Main reason for doing all this is so we can fully factor cubics and quartic equations. And the assignment you can see right at the bottom there. Now, after the warm-up, there was actually a quick question. If you want to practice this, you can pause the video and take 3 minutes and then see if you can come up with the answer. And if you did try that, I would recommend multiplying these two terms together and then multiplying these two terms together. So basically make two trinomials and then just use the method that we looked at in the previous lesson. You end up with 9 terms, and when you combine them, it should end up with that. Now, the first thing we're going to do is we're going to continue the work we did last time, but we'll look at some slightly stranger questions. Now, you can tell this is an AICE question straight away. You can see a norm. This looks perfectly fine at the start until you see this here, AX and then B. So we're missing some terms, and we're going to have to find out what they are. Now, we do see here when something's divided by x minus 2, the remainder is 25, and when it's divided by x plus 1, the remainder is negative 5. So notice there's two equations there with two pieces of information, and notice here we have two unknowns, a and b. So this is your classic systems of equations questions. We've just got to figure out how to set this up. Now, the one thing at the very end of the last lesson that was super important, if you only want to find the remainder, you don't need to do long division, you don't need to do synthetic division, you just need to substitute in the value that's the opposite of the factor. So instead of plugging in negative 2, you just plug in x as positive 2. So basically whatever value of x makes this equal to 0. 2 minus 2 is 0. So we can write an equation based on that. And I'm going to do them both side by side. So all I'm doing here is I'm taking this equation, but wherever I'm seeing x, I'm substituting in 2. And when it says the remainder is 25, that means that it equals 25. And for the other equation, when it's divided by x plus 1, that means I'm going to substitute in negative 1. Then the remainder is negative 5. So that means it equals negative 5. If you go ahead and distribute all these and also collect your terms together, normally when you have a system of equations, you normally have something x, something y, and then a number. So same idea. You kind of want to collect your variables on the left and then numbers on the right. And from here, solving that system should actually be trivial. You should be able to solve this one just by elimination. Both of them have a b, so if you subtract the two equations, b take away b would be 0, and you've eliminated one of the variables. 2a take away negative a would give you 3a, and 13 take away negative 2 would be 15. So a is 5, and trivial if you substitute back, you should see that b is 3. 2 times 5, add 3 is 13, so therefore b would be 3. So a very common type of question, one that's definitely worth spending a little bit of time practicing. So if you have your textbook, you should work on exercise 1C, 5 through 14, probably for about 15 minutes. That probably won't be enough for you to finish all the questions, but it should be good enough for you to figure out, do I need to spend longer on this, or did I spend enough time just within those 15 minutes? A lot of students often pick this one up very quickly, and as it's more about solving systems of equations rather than the division part, it might be one that you don't need to spend quite so long on. Now, I also dug out a question from October, November 2019, just so you can see the type of questions that they're actually going to ask you. And I picked this one particularly because it was slightly different. Normally they ask you to find the value of a and b, and this one they asked you to find the value of a, but they actually placed a twice within the expression, which I hadn't seen before, so I thought that was worth looking for just straight away. So they've given us our equation. They said a is a constant, so just a number, and it's given that x minus 2 is a factor. Now, the very key part about this one is as well, if it's a factor, it means that when it divides in, there is no remainder. The other questions we just looked at, they all specified what the remainder is. So when it says it's a factor, you need to know that the remainder is 0. So what we do for this is a 2-point question, so it can't be anything too clever. Plug in 2 for wherever we see x, simplify, combine terms, and then you can go ahead and solve, and you should be able to find out that a equals 4 pretty easily for this one. Using this value of a, factorise this completely. Factorise, I know it's spelled with an S there, that's more the English word. Normally you just say factor in America. In England we say factorise when you want something as a list of factors. Completely, so I'm going to use synthetic division. The fact that this is cubic means it's not going to be easy to factor, so I want to split it up into a linear and a quadratic if I can possibly do that. So I'm going to use the fact that x minus 2 is a factor, and that means that I know that 2 is a root. Now I put it in a different color here, and whoops, I normally put a square around this. It looks like I'm going with a circle this time, and a very big circle. And then we can just go through those steps that we did before. So you bring down the first number, 4, multiply these two numbers together. 4 add 8 is 12. Multiply these numbers together. Add these two numbers together. Multiply these two numbers together. And importantly, on our last step, it is 0. That means there's a remainder of 0, which we know because it says it's a factor. If this wasn't 0, then we know we've actually made a mistake. Now, we still have to interpret what this actually means, though. So the 4, 12, and the 9 refer to 9 is the number, 12 is 12x, and 4 is 4x squared. The x minus 2, of course, comes from this original part of the question up here. And you could use whichever method you like for this. I noticed that 4 and 9 were both perfect squares, so I quickly realized this was actually 2x plus 3 all squared. And that's how you would pick up your last point. So that's one of the reasons why we needed to do synthetic and long division last lesson. So when we come to factoring more complicated equations like this, then we'll know how to do it. And that all works brilliantly, assuming they give you a factor. So if they don't give you a factor, these questions are going to be more difficult, and that's really the second part of this lesson here. So just a quick recap of what the factor theorem is. If you know something is a factor, you can work out what the root is, and vice versa. If you know the root, you can also figure out what the factor is for that question as well. Now, the rational root test used to be covered in Algebra 2. I'm not sure if it still is anymore, but basically there's a few steps that you should try and follow for these questions when you're trying to factor a whole expression. So first you should find a root by trying factors of the constant term. So that's going to be just the last term by itself, just the number. I use synthetic division to find a linear factor. You can use long division if you wish, but with it being linear, synthetic would be the easiest method. And then you're going to factor the nonlinear expression. If it's a cubic equation that you start with, you'll be factoring a quadratic. If it's a quartic equation, you'll have a cubic, and you'll actually need to repeat this process for a second time, and then you can factor the quadratic. You can also use this method for solving equations as well, depending on the wording of the question. So the type of question we're talking about is something like this. Now, I've not put in every term deliberately because the middle terms here aren't really important. The 24 is really the important part. So I've got to think of numbers that multiply together to make 24, or numbers that divide into 24. I guess factors probably would be a better way of saying it. Now, normally people come up with 1, 2, 3, 4, 6, 8, 12, and 24 fairly quickly if you give them the time. Don't forget also negatives work as well, because they're not going to leave a remainder either. So you can have plus or minus 1, plus or minus 2, and so on. Now, it is important that you try the smallest factors first, because this is kind of a guessing game. We don't know what the answer is. We're going to try something and then hope it's correct. Now, to show you with 24, I've come with all the possible combinations of 3 whole numbers being multiplied together. And what you should notice is from this, can you see that the majority of them actually do start with a 1? Once you get to numbers 2, you can see there's less of them. And actually, as you get to the biggest numbers like 24, only one of these 6 possible answers actually has a 24 in it. So when you're trying your factors, don't just pick random numbers. Don't just suddenly see, oh, I notice 8 works. Let me try. Start with the smallest ones first, because that's the most likely to be the correct answer. And then if positive 1 doesn't work, try negative 1. If that doesn't work, try positive 2, and so on. But that will definitely speed up your questions that you're going to do. Now, there's just one example for this, because most of the steps are things that you've done in the previous lesson. So solve x cubed plus x squared plus 4x plus 4 equals 0. If the question said fully factor, I would be using the same method here. So I'm looking at this last number here, this 4. So I've got to think of numbers that multiply together to make 4. So I noticed that 1 and negative 1 would be factors. So I'm going to start with 1. I'm going to plug in 1 into this expression here, wherever it says x, and see what I get. Now I get 10, so that's not 0. So as there's a remainder, that means that this is not a factor. I then move on to the negative of that value, and you will notice that if you substitute in for this one, you do get 0. That's what we're looking for. So once I've found out negative 1, I can write it out as a factor if I wish, if I want to do it by long division. I'm going to stick with a negative 1 and just use that root, and I want to go into my synthetic method from before. So x cubed is 1x cubed, x squared is 1x squared, 4x is 4, and 4 is obviously just 4. Make sure there's no missing terms here either, otherwise you would need to put a 0 in as you're writing your answer out. Now, I already filled this one in, but just to show you where the numbers come from, I brought the 1 down, I multiplied these two numbers together, I added these two numbers, I then multiplied these two numbers together, I added these two numbers together, I multiplied these two numbers together, and then I added these together. Notice I finished with a 0, so I have a remainder of 0, which is good, and that gives me x squared plus 4. Now, I already know x plus 1 is one of the factors for this one, and if you tried like the quadratic formula or something, you'd find there's no solution to this question. If it was x squared minus 4, of course, you could use difference of squares. So what we actually do is, you kind of use difference of squares, but you use it with imaginary numbers. So you might have forgot this one from Algebra 2, but x squared plus 4, you could write as x minus 2i, x plus 2i. And the reason that one works is this last term here, negative 2 times 2 is negative 4. I times I is I squared, but remember I squared is negative 1, so negative 4 times negative 1 gives you positive 4. And that's probably one of the more complicated ones to do, which is why I included this one as one of the examples. Now, you're not always going to get nice answers for these questions that do factor as well. You might end up with something that doesn't factor. If it says solve, then you're just going to go ahead and use the quadratic formula, which you used in Algebra 2 and Algebra 1. So there's quite a bit of variety in these questions, and you're not going to know necessarily just by looking at the question straight away which one you're going to use. So the exercise that you're going to do, the first 7 questions should be fairly nice to do. I put all of these ones as solve rather than factor, but you could easily do factor if you needed to just by writing down the opposites using the factor theorem. And once you get on to the next questions, 8 through 14, this is ones where you start to get ones where you have those negative solutions, the imaginary solutions, and you also might have ones where you need the quadratic formula as well. And also we're starting to jump up in the powers here as well. So most of these were x cubed to begin with, but you can see at the end here we have gone to x to the 4th just in case we have to come across that. And also watch out for questions like 11. See, there's missing terms here. There's no term with x squared here. So when you do your synthetic, it's going to be really important that you put in a leading 0 for that question. The answers for this will be given next lesson, but for right now, I think that should probably do that for this one. As always, go practice. That's the important stuff. If you need additional help, then there's the links down below, and that will do it for this video.